Hello, this is Craig, and this afternoon I'm using Fusion 360 to create a part for my CNC plasma cutter, which is a Langmuir Systems Crossfire Pro. And this is in response to a comment I made to another YouTube creator's use of his machine. Now he's building a Baja racer called Honcho, and he fabricates all the parts out of sheet metal, and he uses his plasma cutter and welds everything together. In his video, he models something in 3D, and then he creates a flat, and then he cuts that out and welds it together. So I've learned a little bit more than I think Dave has. Let's look and see what he's doing. So here's Dave, and here's Honcho behind him, and he's creating this lower swing arm for the front suspension. And what he ends up doing is going through all the modeling that he does in Fusion, and then he creates the part at the end to help some of his viewers, or that also have a plasma cutter and they want to learn how to do this. So I've learned a little bit more how to use the sheet metal component in Fusion 360, and also I'm creating a parameterized design so that if there's some modification to your design along the way, you can just change a parameter and all the design itself, all the design changes occur automatically. All right, so here's my design here. It's very similar to Dave's. But I use parameters to define everything in my design. So what we're going to do first is I'll explain what parameters I have. So we have this distance from this edge to this edge is the length. This back here is the width, and naturally this is the height from the top down to the base. Underneath here we have stock thickness that you want to weld this out of, and then these internal ribs, how far apart they are. And then I have over here where this edge begins, where this edge is with relationship to this end is I'm calling the edge offset. The other thing I have is you can program in you can set in a parameter where this peak, or I'm calling it a crest, where this crest is in relationship to this end over here as a percentage of the length. So with that, let's go ahead and go back over to my design, and I'm just going to go ahead and show you how I create some parameters. So the first parameter I'm going to bring up. I'll show you where I got this thing. Very first thing when you open up Fusion is you want to set your units for the design, and we're set over here to inches. And then you want to come over here and you want to say create a new component. And we're going to name this component swing arm. And what that does is now we're going to work in the swing arm component, and this is kind of makes things a lot easier when you do when you go over to the cam portion of this, or actually in the sheet metal part. Okay, so we're going to go ahead and save that here. So the parameters that I end up having are width, length, height, like I said, the bearing diameter, the edge offset, crest percentage, stock thickness, and the rib spacing. So I just make these values something. So we're going to be over here on the top. Let's first click on the top. So this is the top down view. So we're going to first create our sketch on this plane. And then we want to come over here and just draw a rectangle. We don't want it to have any dimensions yet. These are all blue lines, which means they're not constrained yet. So let's add some constraints. So first thing we want is this this line right here. We want it to line up with this axis over here. But you see the axis aren't even turned on here. That's because the origin is not shown. So we click on that eyeball, and then the axis actually shows up. So we're going to create a coincident component from here over to we can create it over to there. So now that line turned black, so now we're coincident to that. We're going to set a dimension of this line right here to be length. And you just start typing in, instead of a number, you type in your parameter, and it brings up a pop-up where it tries to guess what you're typing. and then you can just hit return and you set that right there. All right, so we have another dimension here. This is the width. This is the stock thickness. We're going to come down here and say fit. Okay, so this is our fit here. And we, let's go back over to my design here. So what I'm going to end up doing is drawing this design. Let me see if I can get this thing. So I am going to draw, here we go. I'm going to draw this rib, and half of the top. And then I'm going to use this feature over here, this function called mirror. And I'm going to mirror all that across a plane, the XZ plane, and then it's going to automatically create the other half of the design. So what we're interested in is creating half of the design in here. So this distance from here down to that point, this is going to be rib spacing divided by 2. You can type in functions into your distances. And then we're going to draw another rectangle, but we want to use a rectangle that is a 3-point rectangle. And you can see that if you click on these 3 dots over here, you can say pin to toolbar or pin to shortcut. So I pinned it to my toolbar, so you can see it up here. I have the 3-point rectangle, so we'll go ahead and click on that, and we're going to create a 3-point rectangle. And again, we don't want that to be defined yet, or we don't want it to be constrained. You'll notice down here on this rectangle is fully constrained, which means that it's locked down and nothing can move in it. We need to do the same thing up here. So we want to set this distance from here to this axis to be the rib offset. So we'll do our dimension tool here. I'm going to pick that point to the origin right here, and this is going to be the edge offset. And this point to here is actually the length. So we're going to click that guy and this guy over here, and we're going to make this the length. We will continue on here. So we're going to make this the stock thickness. All right, so at this point we can move it up and down. What we want to do when we do an extrude, and if these 2 rectangles are overlapping in any way, when we do an extrude, it will create a single body. So we don't want these to actually be touching, but we want them to be close enough. So what we want to do is we want to create a dimension from that point to the origin here. We want it to be here, and we want this to be rib spacing divided by 2 plus the stock thickness. That's going to get us onto this line down here, and we're going to add some little small numbers so that they don't actually touch, and I'm going to add in 10 thou. Okay, now why is this thing still blue? It's still blue because this thing can rotate up here. Like it could be, this point here could be slid up to here and change this angle. So we want to set this point to down to the x-axis with a dimension. Let me do this again here. Dimension. We come over here, and we're going to make this the width divided by 2. And it should be, why is it not turning all blue here? All black, I mean. Well, let's continue on. All right, so we got this piece here. So we're going to do an extrude first, and we're going to pick that there and this here. We're going to rotate a little bit. So we're going to drag this up, and we're going to drag it up by the height. And that height is too short. So let's make this about 5, and we'll make this diameter 2.5. All right, so this is our part here. Then we're going to create another sketch on this plane right here. All right, so the first thing, so we're going to go down here and we're going to say that we're going to rename this sketch here to be the ribs. Oh, stop. Come on. Ribs. I'm going to do a new sketch on this plane here, and this we're going to put in the bearing cutout. And we're just going to draw 2 circles first, and then we're going to dimension one of them to be bearing diameter. We can dimension this one too, or we can select them both and say equals. And then we want this center to be right on this axis here, so we're going to we need to move this over there, and we need to actually have it coincident, that guy coincident to the axis, not the point there. And then this distance from here to here, let's get this somewhat nearby here. Distance from here to here is the length. There's probably a lot of different ways of doing this. That distance there is bearing diameter divided by 2. And this distance is the same, and we can do something else here. So let's say that's distance from here to here. You see, while it's highlighted like that, you can actually click on this one, or you can click on this dimension over here, and it'll make it the same. Alright, so we'll go ahead and save this here. Now, we need to draw some additional lines in here. So what we want to do is come over to our line tool. We are going to just draw kind of a profile here, and we're going to go ahead and put some dimensions on this as well. So from here to here, that is the length. And this one is coincident to the axis. If I can get my act together here, I'm trying to do things too fast here. This distance, all right, wait, this one here, from here, come on. No. From here to down here is going to be the bearing diameter. Same with this one over here. This one is the height. And from here to here is the length times the crest percentage. Right, so if we come over here, let's say we open up our parameters again. Let's move this around a little bit. And let's change some of these parameters. So here's the length. So let's make this 22. You'll see that everything changes. Or if we want to change the height to 4, and everything is kind of locked in here. We don't have the edge offset yet, but we're not gonna use that yet. Oh, we know we did use that in the other sketch. All right, so we're gonna go ahead and close that up, and we are going to finish this sketch, and we are going to name this one bearing cutouts. Well, yeah. Let's just call this cutouts. So we want to actually do some extrudes now. So we're going to extrude this, and we're going to make sure I'm moving it this way. And when those turn red, that means they're going to do a cut, which you can see over here as a cut. Now, how far do we want to go? You can make this wherever you want to go. All right. But if you include this cut in an assembly, and you just arbitrarily make this wide, you will end up cutting through some other parts in your design. And also, if you want to change the width with a parameter, you may not have made this cut large enough. So what we really want to do is we want this cut to come right up to this edge here, which we have actually defined as width over 2. So we've cut everything out like that. Now at this point we could do the reflection. We'll turn off our sketches over here. I'll just show you kind of really how you do a mirror. So over here you end up picking your type to be bodies, and you're going to pick the 2 bodies you want to do. Then you pick your mirror plane to be this axis, and now you have 4 pieces. And if you click down here on your bodies, you can see that we have 4 bodies, but we're not going to do that yet. Also down here in your timeline, I have a mirror icon in my timeline, so I'm going to delete this one because we're not going to do that quite yet. All right, so let's create our top piece next. So our top piece, we have to turn our cutouts layer back on again. And we're going to come over here to the sheet metal component, and we're going to create a flange. That's this guy here. This is a flange, and you can also get access to this under create and just pick flange. And what flange is looking for is something to make the flange out of. So you can just click on this line that we put across the top here. And what now it's asking for is what is the spacing that you want to have. Now if we rotate this a little bit, you'll see that I'm creating this I'm actually creating a sheet metal part with the bend, and everything is being created dynamically as I move this arrow across. But this is the same issue that we had with the cutouts. So back up over here, we want this blue arrow to match up with this edge right here on this edge. So with it, this also is width over 2. Now we need to create I'm going to show you something else that's really pretty handy. We're going to get out of the sheet metal component. We're going to come back over here to solid, and you go over to under modify, and you say split the body. So first thing you want to do is body to split. So we want to split this whole piece, this rib and the edge. We want to pick those guys, and you can see that up here body to split changed to 2, and then we have our splitting tool. You click down here on our splitting tool. What you end up doing is you pick this line up here, and it creates a surface as a cutting tool, and it's going to split those 2 bodies. And these 2 bodies showed up over here. So we're going to turn those off visibly. We're also going to turn off our sketches. So now you have pretty much the design there, and then you want to there's some nuance up here with this little, you may end up having to kind of grind this off after you cut it, because there's a little bit of a radius up here, and that radius is really based on our height, and there's a lot of other things that's based on. You can actually go in and model and take this out, take out that little peak there, because if we turn off the top, the sheet metal component, this edge is actually a very sharp edge, but the sheet metal component itself has a little bit of a radius on it. In this case, because you're welding it, you don't really need to worry about that too much, but you can come in and model what am I doing here? You can come in and model on this sketch. You can model that radius right there as a cutout, you can do a trim, not a trim, what is it called? It is called, what's this tool right here? Yeah, fillet. You create a fillet right across this peak. If you make this fillet right across this peak of the stock thickness, it will create a little bit of a radius over here. We can do that, but in this case we don't need to. You just take that little corner off of the buffer because you're going to fill it with a weld anyway. Alright, we'll turn our sketches off. We'll turn our bodies back on. So now we'll do the reflect, or I mean the mirror. We'll do the mirror, and when we create a mirror, we're going to be over here, make sure your select bodies, pick the top object first. We're going to do this separately because we don't want a new body. We'll actually want to join it. And then the mirror plane is this axis, this plane right here. And now what it does is it created a completely new component. That's the entire width. And then we're going to create one more mirror of that one and that one. Our mirror plane is this axis there. And we're done. No, we're not done. Okay, if you look at the bottom, we're not quite done yet. Because we need to lop these guys off here. This, in Dave's design, he wanted this top to be this edge. The width of the top of his piece is short and it's wide on that end. So let's go over and do that on this side over here. So if we're going to look at it from the bottom, and we're going to turn on our first ribs design, our first rib sketch, and we need to create one more line in here. So we need to edit this sketch, and we need to create a line This is kind of weird. This is okay. Here we go. This is how we were looking at it from before. We want to create a line from that point up to here and have that be our cutting tool. So we're going to add one more line to our design. And we're going to check our design to make sure we didn't mess anything up by doing that. And it looks good. So we want to get back in our orientation that we were before. Well, we're fine, whatever. So we're going to come over here and say modify. Actually, it's not going to quite work. I'll show you why. It'll work here in just a minute, but we may have to redo some of our previous work. So we're going to split the top first. And then our splitting tool is that line right there. And you can see that it created this, no, it created that side there. Okay, but this split right here occurred after we had already done our mirrors down on our history line. And you can actually drag these into history and have them happen earlier. So what we need to do is, let me go back in time to where we just had half of it. And then we end up creating that one first, and then we create this one. And then if we split it, we're going to end up splitting this one single component. But I think we can drag this split to occur before we did the mirrors. And now that mirror is complaining, so let's go ahead and delete that one. And we'll just do that one more mirror again. So we'll do mirror. We'll pick this part here, and as our mirror plane, we'll pick that one, and we'll do join. And that didn't work right. Oh, I mirrored the wrong part. All right, we're gonna let's edit that feature. I clicked on the wrong part when I was picking my objects here. I want to pick that one. There we go. And then we're going to, this cutoff here is we're going to turn that one off. Okay, so there we go. Now our design is complete. We'll turn off our sketches over here, and we're going to turn off our origin. And just to show you that this is parameterized, let's here's another little thing that I use a lot, is I get the, let's say I want to hit this home position. Let's say I don't like the way that this is positioned, but I'd actually like to look at it from this side. You come over here and right click on your home button, and you say set the current view to home as to view. And then now if you're off in the distance and you got things really kind of messed up and you want to hit the home, it just zooms back into this position. All right, so let's create the flat for this this top. We're going to come over back over to the sheet metal component, and we're going to say create a flat pattern. And we're going to click on that one there, and it creates the flat pattern for us. So it actually created a new component over here. So we'll go ahead and say finish the flat pattern. And you can see that it showed up over here as a flat pattern, and I can, as a new component in my design. A lot of features in Fusion, and particularly on the CAM side, want to work with components as opposed to bodies. So we need to take our bodies that we've created in our design and create components out of those. So we'll show you that right now. So back over in our design, and here are our bodies. We want to go ahead and use Control left click and select those, and then right click on those selection and say create components from bodies. And it took those bodies and it created a component out of them. Then we want to do the Control left click again and select all those, and then this is the way that I learned how to do this. There's probably a lot of simpler way of doing this in Fusion in the CAM workspace, but I created derived drawing. I created a derived design with those components. So now we want to create a new design. We're going to click OK. So we have our new design open over here, and first thing I end up doing is I mostly work in millimeters, but today I'll work in inches. And under Modify, if you don't see an Arrange menu down here, you come over here to your Preferences. And I've heard from a comment in Dave's video that this functionality is not available in the free version, but I pay for a license. So under General Design, we're going to enable this Arrange and Simplify tools. And then we are going to, you can see that there's a toolbar item up here, and under the Modify, the Arrange is right down here. So we'll click on that, and it wants us to click on our objects. So we'll go ahead and click on all of our objects. And we wants a plane or a sketch to actually move these onto. And then down here under length, let's say you go and you pick out, you have a arbitrary length of a piece of stock in your bin, and you say you got 20 wide, and it's 20 wide and 30 long. So hit preview, and it's going to try to put them down. And so from the top view here, this is how it would actually optimize the cut placement. If your stock was a little bit, let's say you had one that was, you can see these dimensions are also over here. So let's say this wasn't 20, but it was 15. But this one was longer. Let's say this was like 48. So you got a long strip. And I'm going to hit the preview over here. And if you had that piece, it would figure it out this way. Okay, from there, you're going to take your design and bring it over to the CAM processor and actually create the toolpath for this. So I'm not going to show you that because some people use Fusion for that. Some people, they use something else for that. So I'm not going to go over that part of it. But you have all your flats put out. And they're all optimized to do the cuts to optimize your stock that you have on hand, and so you can make use of what you have, and it does all this. So once you go through all this, it's pretty simple. Now let's take a look at one more thing here. So we're going to hit the save here. So let's say this isn't long enough. We want to make one that's a little bit longer. So we'll come over here to our parameter page, which is under here. It's under change parameters. Sorry, I just automatically do Control P. And let's say that I wanted to make, I don't want it to be so high. Let's say I want to make that a 3. And then I want to make it a little bit longer. All right. So here's our piece now. And if we hit the save, the question is, if we come back over to our design, our flat panel, our derived design, you'll see that we have this little warning arrow up here. It says, component is out of date. Click here to update the out of date reference. So we'll go ahead and click there. And what it's going to do is it's going to recalculate this entire thing. So now this is how it would cut it out. Now how cool is that? You completely change your design, changing a few parameters, and everything is filled out. And if you're using Fusion's CAM, that will also be reflected over there as well. So make long story short, hope this helps Dave as well as Dave's viewers and other people that actually watch Fusion to learn how to use Fusion as a CAM program or CAD program to generate a design in 3 dimensions and flatten that out using Fusion's sheet metal tools, and then output that over and have that either water cut or plasma cut or whatever you end up doing on your side. So I hope that really helped out. I know that this is the way that I learned how to do this design, and by no means did I just automatically figure this out. This took a long time to figure out, but I knew that there was some way to do it, and I ended up doing it. So I just showed you a little example that's pretty simple. Now, what am I going to use it here in my lab for? I think I want to create a vacuum tube audio chassis, and I want to use this exact methodology to apply using Fusion to actually create those 3-dimensional designs for amplifier chassis, and then be able to flatten that out and cut that on my Langmuir Systems Crossfire Pro plasma cutter. All right, if you got to this point, thanks for watching, and we will continue on here.